In this video, we're going to see how to generate multiple design iterations using random component in Grasshopper. And then we're going to see how to find out the best design using Galapagos optimization. What's going on, fellas? I'm Geo and this is Geo Creations. Let's jump right into the video. So here we are on Rhino, and this is part 3 of Rhino and Grasshopper Beginner series. If you're a complete beginner and if you haven't watched the first 2 videos, I would suggest watch them and come back here. If you just want to know the content of this video, just continue watching. Let me open Grasshopper. Now I'm not going to use any sort of plugins except for bifocals, which again, as you know, it's not going to affect any sort of output. So you don't have to install this. It's just for you guys to see the name of the component. I'll try not to cut this video so you'll be able to follow along with me. So yeah, let's get started. First, I'm just going to blow this up. So we're going to see the output here. So let's see what exactly random component does. First, let's generate something random, I would say. Okay. First, let me keep a point over here, maybe. And I'm going to move this point, like an array, like move this point along y-axis, that's green axis. So let's say I want to move this point in a series. All right. Series. So here's series, and I can move this point in a series with motion y. So I'm just going to type y. So that's y vector, unit vector as an individual, unit means 1, right? So unit vector, so 1 meter, it's in meters, so 1 meter in y direction. So we have to do this in series, we have to do it multiple times, right? So what I'm going to do is, I want, let me connect this. By default, it is 10 counts. We can change it by changing the number over here. Let's say 20, for example. So now it's 20. Let me reduce it. Step. I would say right now the step is the distance between each points, okay? So right now it's 1. Now I'm just going to make it 3. And let's add a decimal point, why not? Let's say 1 decimal point. Okay. Like 5.5 meters, let's reduce it. So that's the distance between each point. If you want to change the start point, which I don't want to, you have the option to change it. You have the option to change the start point. Right now, it's fine. I'm just going to keep it at 0. All right, so that part is done. Now, let's say I want to move these set of points in X direction, okay? But I want to move it in a random distance each time I move it, okay? So let me type move geometry. And this time the motion is x-axis. You can see this, x-axis. X. And now I want this to be somewhere around 10 meters to 18 meters, let's say. So I'm gonna start from 10 meters and end at 18 meters. So by the way, if you want to control it, you can control everything at once. And if you add multiple numbers like this, yes, you can control it one by one, right? So, but by no means this is random, and it requires, high labor, I would say. So, you have to manually adjust it. So that's not going to be very feasible. There is also one more way to do this, that is just adding a gene pool here. So the count is basically, the count is 12. So I'm gonna change the count to 12. Minimum 10. Okay, maximum 18, just like what we had here. And I'm just going to randomize it 100%, so that's totally random. So now, yes, you got randomly generated data, and also along with it, you have the option to control it one by one like this. So obviously, this is one way to do it. And for sure, this is kind of random. And you can randomize it 10%, randomize it 100%. So this is one method, nothing wrong with it. But I will go through another method where it's a little more streamlined. So let me introduce the random component. Random. Okay. So first things first, let's see what it's asking for. It's asking for a range, asking for the number of item it wants to control, and it wants to know, like it's not like it's what it wants to know, like it would allow you to control the randomness using this seed parameter. And there's, I guess it's Schrodinger's cat. Yeah. I'm just gonna give the number as same as the count because that's the exact number we're gonna control. By default, it's gonna be like 10, I guess. Yeah. But yeah, we already gave a value. That's 12. That's the exact number of items we need to control. Whenever we change this count here, this is gonna change, right? So one advantage of using random, as we all know, from rather than using gene pool, because this number is connected here, so you won't go wrong, if you connect this number in an optimization plugin. Now the range. So for the range, we need to set a limit. So as we all know, if we want to set a limit, we usually use a domain. Domain would determine the lower limit and upper limit. Not every time, but the one-dimensional most basic domain is construct domain, which starts from the lower limit and ends in upper limit. So domain start 0, domain end 18. So if you connect number panel here, so it'll say what it is exactly. So 0 to 10 to 18 basically. So if I connect this to the range over here, so that's the range of motion that we have, right? And seed, if I want to randomize this. So with this number slider, I'll get like 11 different iterations. So yeah. And that's pretty much it. Now all I have to do is connect it with here, and then we got a random set of points moved across x-axis. And you can see you can control by controlling the seed over here. There you go. And if I connect a line starting from here and ending from the origin over here, I can see it's kind of like a bar, like a graph, right? So it's kind of interesting. If I connect, pull over here. There you go. It's kind of interesting to see how it looks, but yeah, this has little to no purpose existing. That's basically how random component work. And of course, there are multiple other areas where you can use this. Now let's try to create something interesting with this particular component. So let's say I want to create some sort of tunnel where the sides are created a bit randomly, so I can generate multiple different outputs and then possibly optimize it for our needs. maybe using Galapagos. The first, let's probably delete this. Let's say, let me get rid of these two. And let's reduce the count to maybe like 4 or something. Okay, not bad. And maybe reduce the range a bit less. Yeah, it starts from like 2 and end at 5. Yeah, something like that. And as you know, this is the middle part, like the axis of it. So I'm just gonna add a polyline here, just for reference, like, this is where we started. Cool. Perfect. Next thing, I'm just going to move these set of points to the opposite direction. So how can I do that? So move, again, you already have it here. The same sort of geometry, the same motion, but this time it's the opposite direction, right? So yeah, I'm supposed to add this from here, sorry. Same sort of geometry and the same motion, but this time is going to be in the opposite direction. So I'm just going to add a negative component over here, and then as we can see, it moves in the same way but in the opposite direction. But if you want to add a different sort of random parameters to this side, you can do that by basically creating another range, and then yeah, you'll be able to do that. Yeah, you'll be able to do that. And then if you want to control both of them using a single seed, you can probably add one number to the seed. So whenever you do change this seed, the other one automatically changes one number further. So you always get something random out of it. But for this exercise, I'm just going to keep it symmetrical, just for making it more appealing. Okay, there you go. Yeah, that looks like a bit better because it's symmetrical. It's random, but it still looks good. So yeah, let me increase the size a bit like that. Cool. All right, so as we discussed, I'm just going to create a tunnel with this. So for creating a tunnel, I probably have to create some set of arcs over here. So for this particular exercise, I'm just going to use an arc called by arc. There you go. And I can probably get rid of this here. So this is the first set of points, start point. And this is the second set of points, end point. Start tangent, let's say I want the points to be started from here along with Z direction, like here. So I'm just going to use Z vector, unit Z. So that's the start tangent. And end tangent, I'm just going to, if I add this, it'll try to end up in positive direction. I don't want that. I just want to end it as a proper arc. So I'm just going to add a negative component to the end tangent. So we'll get something like that. You could control the tangent and make it, slightly curved on one side by adding a line as the tangent. For example, let me show you something real quick. Maybe if you want to, probably you can add a line like, so let's say set one line from here to here. And if I add like that, so you can see you'll be able to control this tangent like that, right? if you set a line like this, yeah, that's how a tangent would work. So I'm just gonna make it like properly z-axis. That's fine. Yeah, so far so good. Now to join all together, I'm just going to use loft with by arc. So yeah, we got everything. And I'm going to hide all the other stuff, all the previous stuff. Okay, cool. Now, this is the number slider that we're going to use to control the randomness, right? So at the moment we got like 11 iterations. So iteration 1, 2, 3, 4, and like, to 11. If you want until 100 different stuff, yeah, you can do that, right? You still have the chance to change the range, right? So yeah, so you still have all options to work with this, right? So now obviously this is not the most interesting piece of work, so let's make it somewhat interesting by using let's map some geometry as usual, like we have done this as a ritual for the past 2 tutorials. Let's do the same thing here. Let's map something on top of this. So what can we map? Like what kind of unit or module can we map? So let me go on top view and let's create something in Rhino maybe. Let's create some sort of geometry. So I'm going to create, let's start with I'm gonna freestyle it. I don't have anything in mind at the moment. Let's do something interesting. Let's try to. Okay. So that's a square box, fine. And now I'm just going to add a pattern over here. So I'm just going to make a arc like that. Okay, that's fine. I'm just going to offset this. So offset through point, and I don't care about the dimensions at the moment. Okay, fair enough. Now let's trim down the unnecessary stuff like this and this. I'm just going to loft these two. Loft, okay. Let's go to shaded. Cool. And let's say, let me turn on this control points. Yeah. Let's say I want to lift this up a bit. A little bit. Fair enough. Shaded. Okay. And then I'm just going to add a thickness. Yeah, there we go. Let's do the same. But yeah, with the same, like, let's just flip this maybe, yeah. -1. And then let's flip this in this direction. -1. Not bad. Okay, so this particular geometry is going to be the module, like the unit. Let's still, yeah, we can make it a bit more better. Let's try. Yeah, let's try to cover up everything. Okay, perfect. Alright, cool. Let's not overthink it. That's fine. I'm just going to get rid of this curve. All good. Now I'm just going to import this as mirror. So set multiple VREPs. So there you go. And then to map on top of it, would be better if we convert this into a mesh, because if we keep using polysurfaces on top of a complex geometry, it would take time to load properly. So I'm just going to convert this into a mesh. So let me maybe go to wireframe to see this clearly. Or else I can go to another layer and hide this. Perfect. All right. So now I'm just going to convert this into a mesh. If I just type mesh, I'll get a mesh floater. And if I connect it, it will obviously be converted into a mesh. To reveal the meshes, I'm going to use Control M. And this is not bad. I can still use this and still work with it. But if you want to have greater control over your mesh, you can use BREP mesh. Or mesh BREP, yeah. And now you can see it has a bit more segments, and these edges are a bit clear. But I can still use mesh settings. I can create a custom mesh with this. Now at the moment, it doesn't look really appealing. So you can change the minimum count and maximum count and all those stuff to experiment with how could it work at the end. So minimum count, yeah. If this goes to 0, this is how it looks. And let's see. Yeah, max count didn't work. Nothing's happening here. It's fine. Simple planes, let's invert to turn it on. So that's simpler planes. I'm just not going to use it because it's going to twist and turn, so it'll be easier for the mesh to have some seams here, stitch seams, so that'll try to merge some of the seams. So I'm not trying to do that. Refine, yeah, it's already refined, I guess. Fine. Aspect ratio would try to maintain a certain ratio here. So if you want to give an aspect ratio, so 1:1 is 1, right? So 1 would give you some sort of square aspect ratio. So every chord would try to maintain a square shape. So it depends on how you look at it. You can I would say you don't have to change anything here, but yeah, you can manipulate how your meshes should look. But for now, I would say this is enough. And let's just keep it like that. You can experiment with what happens if I change the max edges or minimum edges. Yeah, so this will reduce the edges. Yeah, fair enough. Okay, this looks a bit plain. Let's try that. So this is max edges. Cool. Anyway, let's just stick with it. That mesh looks a bit clean. So Control M to reveal or hide the meshes. Okay, I'm just gonna hide it for now. So these are the set of geometry that we're gonna use later. I'm just going to make it bring it here and then cool. Now what I'm going to do is I'm going to morph this geometry on top of this. Let's hide this maybe. For morphing, I'll have to divide this into multiple pieces. So I'm going to use iso trim. Here's a surface. Domain would allow us to divide this into, divide domain squared would allow us to divide this into, multiple pieces using the UV lines. I explained this in a simpler way in the first tutorial. You can check it out. So now we got a bunch of surfaces over here. Like, it's divided into multiple single pieces. Now it's on the surface. Now what I'm going to do is I'm going to use surface box and probably add the surface over here. And the domain would be over here. There we go. Right. And now we can reduce the height, maybe 0.3. Okay, so we got like, we just converted this surfaces into multiple boxes, and using box morph, I can morph this object into these boxes. So geometry is over here. It's already aligned to the XY plane, so I'm just going to use this as reference. And there we go, we just connect it here. And here, if you look at it, it's not properly working as we intended, because this has multiple geometries and it would get confused what to insert where. So in this case, I can just graft it and it'll work perfectly. All right. So graph would basically put the individual object in its own group, so then it'll work properly. Okay, perfect until now. So let me hide this. So that's our geometry. Now let's give a preview, maybe custom preview. Maybe let's create some sort of yellowish tint, like color. Let's make the hue something like that. And I just don't want you guys to assume that my favorite color is yellow or something. It's just I just got used to it. Like, all my renders are a bit warm. Just creating sense of brand identity. It's not like I like that or not. It just happened to be that way for a long time, so I just stuck with it. So yeah, anyway. So now you can see, it's an interesting pattern all over. And I'm just going to, maybe let's try rotating this bit from here. I'm just going to, rotate it the opposite direction. Let's flip it, -1. Yeah, it's a bit better, I guess. We'll see. Let me change some render settings a bit. Let's maybe add ground plane. Yeah, perfect. Right, so now I'm just going to check different iterations changing this by changing this number slider over here, which is the seed for random. I'm just gonna see how it looks. So you can see, like, we can generate a lot of different types of output within seconds. Now I'm gonna use Galapagos to optimize it for maybe the highest volume or area. So let's say I want to find the largest output out of this whole bunch. So right now it's fine, like, you're free to select one that you like and then stick with it. Yeah, that's 100% totally fine. And there's not the single application. There's not one single application for this. You can create multiple different types of stuff with this. But let's say I will still want to use this random parameter to add some dynamic value to the output. But still want to explore what are the conditions we can give it and how we can manipulate it, right? And again, we can also change the UV count here if you want. By default it's like 10 and 10, but yeah, you can change it to whatever you want. If something like this, like a boxy look is what you wanted, you can reduce it. Or if you want it more, like a lot more smoother, you can increase it, by the way, yeah. If you reduce it, it'll look like this, which is not bad. You can still work with this, still looks cool. And yeah, we can work something like this, work with something like this. Yeah, let's see how it responds to this. Okay, which is not bad at all. Like, it still looks really good. I feel like we can stick with this kind of output over here, and we're going to generate multiple output with this. I'm going to involve Galapagos in here. So this is like generative design concept, okay? So we would go through generative design ideas a lot more clearer in upcoming sessions. This is just like an introduction for this evolutionary solver and how this could work. So basically, let's say I want the highest surface area calculated from this particular loft. So I'm just going to use area. So I want the highest surface area. Okay, so like if I connect like area to a panel, you can see there are different surface area coming up. If let's simplify it with an integer thing, but yeah, I just got rid of the decimals just to see it a bit clearly. So yeah, 273. So we can go through it and let's we can check what is the better area. So it's like like 414. It's like it's a bit big. So the biggest one would be like a bulgy, would have a bulgy look. So far we found like something 400, like a 429 is so far the biggest out of this whole bunch. So let's find the biggest out of this 101 iterations by using Galapagos optimization. So you can either set like the condition the biggest or smallest, or somewhere in between if you did it right. So for now, this is one single parameter. You can involve multiple other parameters, but for now we'll stick with this. Let's not complicate things right at the moment. So now I'm just going to put this in here, and this is going to be the fitness factor, so that the largest value would be taken in, and the genome was going to be the seed value over here. So this is the number. The genome are going to be number sliders that would change the shape of the geometry, basically. All right, so yeah, let's keep it somewhere here, maybe. Cool. Now let's run the simulation. Let me save this just in case. Okay. Let me double click here. So I want to maximize the fitness value. So I'm just going to hit on to maximize. That's fine. Let's say, let's keep it somewhere like that. It's fine. And in the solvers, you can set a time limit. For now, I'm not going to set any time limit. The more time it runs, the more accurate the result would be. Basically, how this evolutionary solver works is it tests out different iterations, and if it finds a better version of it, and it'll take that set of default, the best 5% data, takes it into a different set of simulation, runs it all over again, and then find the best out of that. So it's basically like evolution. So the best gene survives, basically. So that's what's happening here. So it'll test out everything, and the best set of genes would be taken into consideration, and it will start evolving. And if you want it more accurate and more predictable, you can use gene pool, which you can use gene pool instead of random parameter. That would be a bit more predictable. But the problem with a gene pool is we obviously know the highest value of all number sliders. Like if you ramp up all number sliders in gene pool, that will be the highest value. But in random, you still have some constraints. You still are going to get some interesting output with random parameter. So yeah, without any further ado, let's start solving it. Yeah, let's see. So now you can see it started the solver. You can see this graph over here. Now it means it's testing a lot of stuff and still figuring out what it is. And once it's starts settling down, you can see you would notice that the graph would become smaller, and this line would become smaller as well. Right now, these are random parameters, so it would struggle to find out the patterns and how what kind of circumstances are making certain patterns. Is because it's completely random. But if we give a proper gene pool, this would work a lot more effectively. But yeah, let's see how it ends and how it goes. So right now, I guess it's kind of run through all 100 iterations and settled on the one that has the highest area. So if we check the area over here, let's go here. Let's check the area, and yeah, and obviously this is the highest. When we checked, this is the highest. So as this is a completely random generation, it's just a seed. That's what controlling the whole thing. So it wouldn't basically have a proper pattern recognition to optimize it properly. But we just found out the largest area, like the stuff that has the largest area. So that is successful in that regard. But let's say we have certain parameter and we have to adjust it according that parameter. So instead of using the random component here, I'm just going to get rid of this completely. And then I'm just going to give a factor a gene pool data. So what's the number of items? 4. So I'm gonna go here, and then let's set 4. Okay, there you go. 4, and the gene pool could range from, let's say, minimum 2 meters, maximum, let's say, 5 meters. And then if I connect it here, so now I'll be able to control it one by one properly like that. And then I can randomize it for sure. Yeah. But the thing is, if you run, this won't be random when you connect to Galapagos. It'll just ramp everything up in here to get the highest value. Obviously, that's the most obvious answer. So Galapagos would do that. Let's just try, why not? Let's see, just as an experiment, let's see how it actually works. So let me bring this closer here. And then I'm just going to click here and again maximize. Fine, solvers, start solving. Now it'll test out all possible iterations. Now you can see that instead of one number slider, it has like 4 different number sliders. And once this becomes linear and thin, it is a progressive, basically really a progression. So there's nothing left for imagination. So once it's completely done, it'll just find the biggest output. Haven't it figured out this bit for some reason? Let's see. It just tests everything and finds out the best. So if we wait long enough, you would find that it would ramp up everything to the rightmost extent, and that's the final possible output. So it's just testing out, and it's gonna settle down once it's completely widen out. And there you go. It pretty much figured that out actually. There's nowhere nowhere else to go basically, so that's kind of settled down, and so that's the final output. So that's basically how the Galapagos works. So it probably helped you explain how it exactly work, right? Now let's set a condition. Let's see. So at the moment, the only condition is I want the highest the surface area. So let's say the condition is I want the highest surface area, but I don't want to meet these two ends, let's say. Okay, I want to make sure these two areas are not colliding. For example, let's say I want like a bulge, right? So plan about like a curved shape of something like that. So what I'm going to do is, let's say I'm going to create a circle over here and another circle over here. And so I don't want to hit these two circles, let's say. Hit these two cylinders. Okay. So this is my aim. So yeah, let me go to a different layer. Maybe add these two as B-rubs. So right click, set multiple B-rubs. Okay, perfect. Let's hide this maybe, yeah. So let's set a collision data. Collision with 1. And obviously here's the obstacles, and the colliders are over here. So now you can understand that this is actually colliding by seeing over here. If it's showing false, it is not colliding. If it's showing true, it is colliding. But yeah, we may have to flatten this bit. Let's try flatten this. But it is checking it for all these geometries over here. So I'm just gonna use this as collider. So like the surface as collider to make it a bit more easier. So yeah, true, yes, it is colliding. So let's see, to avoid collision, what should we do? So if we reduce this, still colliding, reduce this, there we go. It's still like a little bit. Let's go a bit less than 2, or maybe let's make this so here, and make this here maybe. Yeah, now it's false. Now it's not colliding, right? It's turned into false. So yeah, now we can see the most positive outcome would be something like this, right? But we don't know for sure because we haven't run a simulation yet. But we know almost this is how this should look. And yeah, so now let's say yeah, this is fine. So let's say if I want to add this with Galapagos fitness factor as a condition. So if I get false, I want something to trigger this optimizer, right? Okay, let's see what we can do to add this in here. Okay, So for now, if it's false, it's not colliding, which is a positive response. So for any positive response, we have to reward this fitness data. So let's give a value for this positive response, which is, let's say, 1000, for example. So this is a positive response. I'm going to give this a positive response 1000. Like false is the positive response for us. So we can give the value using dispatch, and here's the actual, output should be. And pattern, it would be like if it's true or false. The pattern would be the Boolean data, if true or false. And finally, I can get the output from here. That's the positive response. This is the negative response, right? So 1000, perfect. And if in case I have negative response, it will be like nothing, like 0 or null. So if I manage to hit this particular object, so now it's nothing, right? So 1000 versus nothing. So Galapagos would learn that this is a positive response and reward that particular pattern. So first, we'll take this area and we can merge this particular area with this one over here. And then I'm going to add these both using mass addition. So now, we know if we maximize this, the most possible, positive outcome would be something that wouldn't collide this with the highest, area, right? And also we have to be sure that this number is not too far from this value, because the more this response, this would probably start neglecting this if it's negligible. So we have to make sure this is not kind of negligible, so we can reduce it accordingly. So it's almost try to make it almost the same, right? Cool, fine, it's fine. Right. Yeah, so that's fine. Let's try it. Yeah, something like that. That's cool. And now, let's run this. Let's try to hide this collider. There you go. Fitness factor would be this. And let's run this again. See. Let's go to rendered view. All right. I'm going to change the color of it. I don't like this. Yeah, that's better. Okay, now, let me go into it. Maximize, yes. Solvers, let's start solving, There you can see. Now you can see it's trying not to hit this area. It already figured out that if it hits it, it is punishing the output. So it tries not to hit it as much as possible. Let's see the best possible result. I guess it kind of reached the best possible result already. Yeah, pretty much. It kind of reached it. Let's stop this. Cancel. Let's go into top view and let's see how this is looking. Let me go and get rid of those curves. I mean, it is colliding with the geometry, but we gave the inner circle, like the inner, was that like the lofted area? So the lofted area, it doesn't collide, and it found the best possible result, basically. It coming as close as possible to this. So actually, it is still really good. And let's give a bit of a bit more freedom. Let's make it like this, maybe. Yeah, let's try with this one more time. It's an experimental thing. Now let's try. So I'm going into this. I'm going to the solver. Let's try solving, and let's see how it reacts to this. Actually, yeah, let's try pushing it closer. Something somewhere around this place over here. Actually, yeah, it is symmetrical, so it doesn't matter how close this is. But anyway, okay, so let's start solving. There we go. Now let's see how it reacts. Okay. There we go. Now it automatically, all of a sudden, like right off the bat, it found the right way to do it. So yeah. So this is comparatively simpler as opposed to, we can go a lot more complex with the Galapagos with multiple data. So as we are just starting with generative design, this is just an introduction to generative design. I'm not trying to go a lot deeper into it. This is a bit more predictable output than we would expect. But yeah, Galapagos would be helpful to run through a lot of unpredictable, yet something that would just something that a human cannot do. Could be done using Galapagos. But at the moment, this particular exercise could be successfully pulled off using by a human, but if the complexity increases, for example, finding the best possible volume for a building according to the radiation factor, right? So these kind of stuff are a bit more unpredictable, right? So though in those kind of scenarios, generative design with Galapagos, already Galapagos, we can use multiple other tools like Biomorph, Wallacey, Octopus. So these are different generative tools that you can use. So for now, this is an introduction to random parameter, how you can generate multiple iterations using using Grasshopper, and how you can optimize your design using Galapagos. Okay, so yeah, that's pretty much it. Actually, I would leave it up to you to explore further with this particular tool. You can tag me on Instagram once you create your own output using this tutorial. I would really like to see that. If you found this video interesting, leave a like and make sure you subscribe to this channel. If you know someone that would benefit through this video, please do share this video. So that's it for today. Catch you guys in the next one. See ya.